So welcome to this Oniro event. So Oniro is an Eclipse Foundation project. It's a kind of distributed operating system or distribution targeting IoT devices, big and small. So welcome to this. And how should we proceed? I would really like it if we could somehow be at least somewhat interactive. So we have, let's say, research 1 hour, I think, in the invitation for this event. So my plan is to talk, let's say, half an hour-ish or so, and then preferably talk about your kind of insight and preferences and questions and project problems and whatever interest you might have on this. So I would say goal for this event would be to answer your question, what is Oniro? So after this, everybody should have an understanding. Then besides what, I think it's a reasonable question to ask that why is Oniro there? Kind of why to have a new project, new platform, new kind of engine for IoT? Because I think quite traditionally in telecoms industry, the problem has been that we have 10 standards, all are quite bad. So let's make a yet new standard that unifies them all. And after that, we have 11 standards. So what are we doing better here? Why is this a good thing? So that is the kind of why Oniro part. And then thirdly, how to try it out and how to join it once you are convinced of the first and second part to be kind of reasonable. So I'll introduce myself then. So my name is, as said, Janne Mäntylä. I have been working in the mobile phone industry for more than 25 years, I believe, actually. But anyway, I was lost to this security topic in year 2000 when Nokia was planning to make mobile phones with an operating system where one could install own native applications. And in one kernel design meeting, I happened to ask the questions that has anybody thought what would happen if? And then I had many threat cases in my mind that what could go wrong. And then that question kind of started a new project in Nokia Research Center. And then that led to signed applications and a PKI infrastructure for mobile phones and a permission model for applications. And to have those, one would of course need secure boot, and to have secure boot, one needs CPU features, and then the whole kind of tsunami of security started to happen in mobile devices. So that's kind of my background, and since then I have been kind of working for various platforms, various operating systems, various chipsets in designing end-to-end secure systems. And now 1 year ago, I joined this Oniro project, or a little bit more than a year ago actually, and helped to kind of initialize the kind of platform security building on that project. But at this moment, I'm not too much contributing for Oniro per se, but it's we have a research center here in Helsinki, which is quite independent R&D unit where we do also independent research. And for us, Oniro is basically just a platform where we can collaborate, we can prototype things on it. If something is missing, we can add it. It's like a collaborative thing. And I would say probably for most of you, it could be something similar. That it's a kind of platform where doing IoT, it just happens to be quite easy. Coincidentally, before this 2000, I did my master's thesis about Bluetooth actually. And funny is that it's, well, I didn't do it on security per se. In the same research group, also security was kind of designed back then. For example, this model where initially it was thought that every Bluetooth headset comes with a secret phone number code, and then that code is input to the device that utilizes it. But turns out this was way too complex for average users. So now I think security code is 4 zeros or something. But anyway, still it happens to be that in IoT, the managing the voice is still kind of not solved properly. One can imagine, let's say if you are in a car, your friend comes on board the car and his phone rings, and turns out that it's your common friend and he just wants to share the call on your car's, let's say, speaker and microphone system. So that still doesn't work. It has to be pre-configured. So this kind of intelligence is something that, for example, this Oniro hopefully could tackle in the future. So about IoT, assume everything is connected, but still consumer devices are fragmented, unfortunately, and this impacts your daily life. Like the example about the car I mentioned, but let's go to your home. You have equipment like a television set. I bought a dishwasher a couple years ago, and that has a Wi-Fi. My washing machine, I think, has a Wi-Fi. My sous vide cooker has a Wi-Fi. I have Wi-Fi lamps, and this was, I think, one of the first ones, if you can see in the camera, this kind of ESP32 based Wi-Fi controlled power socket, which is, I don't know, maybe this was 5 euros or something, or 10 euros in China, I'm not sure, but it's anyway really, really cheap. And it's a quite central piece in many of these home kind of automation things. Let's say the Wi-Fi lamp or Wi-Fi socket. Then most homes have a router at the moment. There are many Bluetooth and other speakers, security cameras. Then in the wearables areas, there are like this Oura Ring, which is also connected. There is the watch, which has connection always on. This headset, for example, is there. They take this headset. Okay, it's kind of stupid move to remove it, but it seems that many of you are not speaking. This has a mechanical switch, which switches it between being a Bluetooth headset and between using the small USB token in the laptop at the moment. So it was kind of disappointing to see that, because configuring Bluetooth is such a pain in the butt that it's rather a physical switch between devices than kind of using some smart software there. Then your other, one could say, IoT devices, for example, cars are nowadays connected pretty well even. Play consoles at home, your laptop or tablet, and of course the phone, which kind of phone companies would like to see in some kind of middle of the thing, because phone happens to be the component that is where the trust anchor is. Your payment bank account details are typically there. So many devices and so little intelligence at the moment, really, in this whole big picture of all these devices. And that was a good starting point for this Oniro to realize that something more is needed. And now these are very siloed. So if you have a IoT device manufacturer, typically they have their own, let's say, software into IoT device, of course. Then they have their own software typically in your phone, which connects to that IoT device, or be it then if it uses your home Wi-Fi, then it might be in their cloud actually. But often still the setup might need your phone there. Then the IoT device connects to the device maker's own cloud, which typically is actually implemented by some. Yes, did somebody ask something? I almost heard, but not. Okay. So the IoT device typically connects to some backend cloud service, which then together kind of make a siloed approach that makes that particular device sort of function in a standalone manner, typically pretty okay-ish, but there is no intelligence at the moment in these solutions. And I did an experiment a couple years ago with several of these IoT devices and connected them to the Amazon Echo, for example, and then tried to kind of with the Echo to control these devices. And it's really messy. Who trusts whom? Where are your credentials, for example? It's really unclear to the user. And kind of how do this, because then the control happens in practice in the clouds between these big corporations, and the user doesn't have control anymore of the kind of trust between devices, and then who or which device control which device, and the whole messy situation, let's say. You can try this out with these popular and cheap devices easily. Then about our device fragmentation. So here we have a kind of background survey of global IoT devices. And 2015, it's just 2 devices per person. 2020, there were 4 devices, and 25, it's estimated to be almost 10 devices per person that are considered IoT. So network things, which I showed also, like this. Like from €5 to a few €100 in that range, you can easily have many of your electronic devices nowadays are connected. And like in the European Union, we shall have a law very soon, this radio equipment directive, which actually requires that if your device is connected, then we have to have things like software update for it. And many of the current engines and platforms, they don't really support kind of maintaining secure software asset in these devices. So Oniro plans to solve that all, for example. So here it says number of applications in different devices. I'm not quite sure how accurate these numbers are, but let's say 4 million plus applications for smartphones, in the tens of thousands category for watches, in TV operating system a little bit less, and kind of cars also have like in the 100 range. And in cars, for example, the safety requirements are pretty big, that even the kind of infotainment applications, you can't run anything there, to my understanding. Okay, I have listed kind of problems in the domain. Any questions there, or thoughts or opinions, or other problems you have seen? Okay, we can move forward then.
Sorry, can I have a question here?
Certainly.
Yes, because my major was logistics, and I also studied something related to the AIoT. I'm really interested in the IoT and AI, this kind of things. I want to know, do you think this can be a good platform in future so that we can connect the IoTs, Internet of Things, this kind of things in our real life in future? Because I think this concept is quite new. Somebody already told me, I think last week. Yeah, thank you.
Yeah, so how did AI relate to the question? Can you repeat that part?
My friend told me one concept is about the AIoT. The AIoT is a concept combine the AI and IoT.
Yeah,
it's like
yeah.
It's like a platform that kind of things like Steam, this kind of platform. On this platform, you can design everything inside, which can use in our real life to make the AI, this kind of technologies in our real lives, to make everything connect. This kind of platform is still in concept. I want to know, do you think is possible and what kind of possible can be used in future. Yeah, because my major was logistics. I want to know how it can be used in this logistics. And you talk the device like mobile phones and the watch and the car. There's so many things, this kind of IoT. But these kind of things are quite how to say, a little bit expensive and it's in that kind of in family, this kind of thing. So I want to know if in personal, like for logistics, this kind of really simple things like delivers, how we pick up the things in futures and how we use the technologies in our real life. Yeah, that is my simple question. I'm sorry. Too long.
No, it's interesting discussion topic also, and for sure there is not a single one answer, but and depends what one means with AI. But certainly when there are lots of devices and kind of this innovative technology is needed, then I think the network itself might require AI-ish like behavior and functionality to kind of configure the world and make things happen. But also the, let's say, if one with AI means the kind of actual capability to compute artificial intelligence like computations, like for example, your phone nowadays has like a TensorFlow libraries and can do lots of AI computation and kind of has machine learning capabilities. That's kind of different aspect than the actual smartness of this here, the Oniro network of devices. And both here, this kind of presentation of mine mentions the AI of the network itself and having this kind of smart logic there. What this does not discuss so much is that if inside these devices you run AI intensive applications, and I think these are kind of separate topics. Both are really relevant. And in this Oniro context, I would say maybe more relevant at the moment is this kind of managing the network of devices. And for example, identifying which device can do what without the user requiring manually to configure everything. Because that manual configuration starts to become pretty complex. And also the manufacturers of the devices might not be able themselves to, assuming there is a lot of different manufacturers who all don't negotiate with each other, that your, let's say, this ring can connect to my phone, but not that other device or something. So configuring this beforehand might be impossible. So there we will need some kind of intelligence. Is that called AI? I'm not sure, but this kind of smart configuration, and I think some people call that AI also. Probably didn't answer very clearly. I don't have a very clear opinion myself that what will the future be in this context and what can be done automatically and where some kind of pre-configuration is needed and where actually manual configuration. But as a user, I certainly hope that all these devices shall not need manual configuration, but there would be as much, let's say, intelligence in the platform as possible.
Yeah. Thank you so much. Yeah. And I got the basic idea. You just talked the manufacturers, one important part, and of course the retainers and also the consumers can be the one important part inside in future. Yeah. But I can consider. Yeah.
But as a professor and as a kind of expert field, I definitely welcome you to kind of contribute into area. And also, if you want to do that contribution inside Oniro, I think the community will be more than happy to welcome you to kind of use Oniro as the platform of choice to kind of experiment with these things and even make products in the future. There is several big companies behind this Oniro, and you would get like a pretty good support. And there is many talented technical experts contributing already.
Okay, thank you so much.
Thanks for the question. Yeah. So, as said, this picture rather like describes that there is device fragmentation. There is a lot of devices with huge number of applications running on them. and managing this network will be challenging in the future if the platform doesn't provide some kind of tools to help. Let's call it smartness or some kind of device AI. So kind of repeating what I already said, so kind of why is this happening? So there is fragmented and isolated consumer device market. This is not necessarily kind of, I mean, this is a sort of factish thing. This is not something that we are complaining. It's a good thing that there is lots of vendors for various technologies. And also technologies tend to be some kind of silos because technologies are developed by humans and they are kind of done in some kind of isolation. But then what we need is a means to connect these silos. There are small developer ecosystems. There are of course big ones also, but still there are different ecosystems, and there will be also. And it's as said, it's also a good thing in a diverse world. And the problem I also tried to describe earlier is that this communication between these devices is enabled by discrete applications that are connected to their respective clouds. And then they synchronize and communicate their data with their particular cloud. And then that creates some kind of silo also, which seems to be difficult to break. And these, let's say, concepts that try to communicate between the silos, they are kind of dedicated one cloud vendor or service vendor communicating with certain devices with the device makers who integrate their client library, which uses their cloud service. And some of these popular cloud operators are famous for doing this kind of signal solution for their only tool. So let's say again, this ring or this power socket Wi-Fi thing, then if you look at those in the stores, they typically have 6 stickers on them that which cloud services they support, because these are silos, and that's in the future that doesn't look very good, unfortunately. It means that there is a couple of corporations who will own things, and if you're outside them, then things don't work, and entering the market will be difficult. So these kind of power setups, from technology point of view, from user consumer point of view, we should avoid those. Then IoT would need common standards to live up to its promise of empowering consumers' daily life, or let's say at least IoT would benefit from common standards. So telecom industry for decades has been based on various kind of standards that companies come together and define how things will be. But in this IoT world, I would say the traditional telecoms way is maybe a little bit slow way to agree on things. And also there is so much innovation happening in IoT field that is traditional, let's all get together and define a standard approach might not work very well. One single cohesive application, it's the kind of Oniro promise that there should be. This little bit of course sounds like let's make one standard to fix all the previous standards, but if this application is free and open, then it as a kind of configuration place, it might work. Then there should be interoperability between devices, one broad traits ecosystem, write once, deploy on different devices, and then it should be secure, and there should be synchronization and sharing kind of thought beforehand how they would work. I would say the interoperability between devices is the kind of one of the most challenging parts here. From the 70s, we have had, let's say, 50 years now. There's every 2 years there is a concept that let's write once and deploy to different devices. I think that was the idea how C language was created and all other standards after that. But anyway, as a goal, it still is unreached, and let's say, I would say for tens of years in one could have said that in 2 years this will be the case, but let's hope this could be kind of one approach there. Then why open source? This is also a huge question for software developers in the industry who has been long a time. I think it's quite easy to kind of explain this cooperability, interoperability, and communication between different toolkits, that it's just easier to do if the source access is there. And in this current Word environment, I would also say that that's one of the only ways to really gain trust and trustworthiness for your software if you open the source. And also in these bigger open source communities which have a kind of bigger integration systems, it's also a way to protect yourself if you open source your solution and integrate it to a, well, let's say Linux operating system. If you integrate your thing there and it gets integrated, then it's a lot less maintenance after that. Whenever new kernel is released, you don't need to necessarily update it anymore. And otherwise, somebody can break your interfaces and then you have to do it all again. But if it's integrated in the open source stack, then it's other people's headache to make their software work with yours. So it's very cost beneficial to use open source. Traditionally, the problem has been that businesses consider their software to be a kind of secret asset that cannot be shared, but this, I would say, is very much understood nowadays that open source is the way to get kind of collaborative open software, be able to discuss the requirements, roadmaps, and features and so forth. So it's just a must, I would say. Then the mission is to achieve the goal of avoiding technology silos through the path of open source. This means providing every device maker with the same technology baseline in an open, trusted, transparent, collaborative way. Same thing said in a statement there. And more on the open source, there's kind of implementation, community, technology, hardware, and applications areas as open source. Any kind of opinions here in the audience about the open source's benefits, or is this kind of sort of clear? I've been working with open source so long time that I can't very clearly even see that what are the other options here if one really wants to make a big impactful system. Okay, let's move forward rather in the topics to this kind of distributed architecture of Oniro in particular now. And I think from the if you have like a few takeaways from this session, then I think here is now the one where Oniro really actually rocks. So it's this virtual resource and virtual peripheral here. Here it just uses multi-kernel design, which is of course true. There is kind of in Oniro stack, one can choose which OS kernel one uses. We support several, so Linux, Zephyr, and Light OS. Sorry for the typo there. But this application developer super device means that the application itself can run simultaneously in several of these devices. And that's called this super device. That you can use services from different devices in the same application. And this library set is something that Oniro has integrated. This kind of, it means that there are virtual resources and virtual peripherals, and there is kind of distributed task scheduling, data management, resource pools, and also security is taken care of. And this is quite big software asset, and it changes the programming paradigm somewhat, and it's supposed to be making them easier actually. That the libraries are well thought of. You just want to output audio, and you just start to output it, and then the system decides where the audio actually comes out from, depending on what kind of devices the user has around him or her. So this is some kind of competitive edge for Oniro, of course. And the kind of positive things is that there is no lock-in to any vendor, not to any partner of Oniro. Oniro is kind of independent. There is no owner in Oniro. It's actually open source, actually Eclipse Foundation owned, and it kind of brings this super device concept, and it brings this so-called blueprint scenarios, which I will describe shortly. Okay, then the AI is mentioned. It's kind of this kind of, but we discuss what does AI mean IoT context, and this is kind of the smart environment configuration meaning now, that it tries to hide the fact that you need to configure many devices, configure the rights, who can and what can use what, which is quite difficult if you have to do it all manually. So Oniro tries to do the smartness for you there. And then about the internals and architecture, I wonder how deep should I go in this event. So we use Yocto, Project, and Bitbake for the builds. I'll do some skipping, and you can interrupt or ask questions, and then we can go back. And there is the kind of obviously kernel layer, system services layer, application layer, and in between the framework layer. Typically it's a Unix-based platform, but there is also Zephyr and other smaller operating systems supported. This is how the developer sees it. There's the Bitbake and Yocto were mentioned. And then with those, you can build it to the, let's say, Zephyr, OpenHarmony, Linux, or FreeRTOS variants. And the applications should be the same. Then source code to production image picture, what kind of concepts there are. It's a relatively straightforward kind of building architecture with the application runtime. There is debuggers, there is OpenHarmony, Linux, hardware abstraction layer, and below that you have then these virtualized hardware concepts. This mentions some of the engines it works on: the Avenger, Nitrogen, Arduinos, and QEMU. We have Raspberry 4, Seco boards, to mention the kind of biggest supported frameworks. And we have security building blocks also to do those trusted operations that the chipset provides. Hardware kind of story. So I think maybe the easiest way for you to get started is to get the Raspberry and an image for that as Raspberry. So ubiquitous, it's the easiest to find. Well, of course, QEMU, you can use your existing PC to work with QEMU because it's an emulated platform. But to kind of test it out and try it out and get it first time booted, maybe the Raspberry is the easiest for you to find. And then there are some kind of Cortex M4 based platforms which you can operate 1 year with a coin battery. So that's the from ARM v8 quad core Cortex 872 to coin operated small Cortex M4. So it tells something about the kind of what kind of devices we are talking about. Goofy is the release, which is this coming December coming out, and some kind of projects that are now being done for this Goofy out there for you to see. So OTA means the over-the-air update, which is essential in any commercial product in the future, as it will be legally required if you want to sell it in Europe, for example. Then the development tools like debuggers and tool chain and supporting various kernels. There is LightOS, there is Linux, there is Zephyr. And then kind of reference hardware wise, boards that I already mentioned, and then testing and infrastructure wise kind of things. You can read these from the Oniro web pages also. Then a thing I would like to mention is this reference blueprints, which is a Oniro concept for kind of building. So Oniro, the project builds like a working device concepts that are called blueprints for various things. And here it's actually I could even show from the if you go to this web page oniroproject.org, and there choose the docs subsection, and there you will find these blueprints, which here are like the smart panel, door lock, keypad, transparent gateway, vending machine. As an example, let's say vending machine. Here you can find what is the device. It's like a real software and computation components to build a vending machine, and it's easy to do it. You get all the hands-on kind of instructions how to do the board, display, keyboard, and it has kind of some kind of trivial software for the setup. Okay, here is the picture of the screen that is kind of the vending machine's UI. So doing actual products is supposed to be, and we try to make, Oniro tries to make it as easy as possible. And here you have kind of command line instructions how to load it and how to build the whole system and how to execute and how to prototype it. I think it's pretty cool concept from Oniro. Or take some door lock from there. It's really like a hands-on how to connect the things with this board and how to get it running. And there are very good instructions, even videos in many of these, that how to get things done. So that was wanted to explain the blueprint concept as it's so central in this Oniro daily way of working. Okay, here's a longer term kind of release map. There was the release Jasmine, Goofy, and which is 22, and Daisy is the year 23 release's name. There is a continuous integration and deployment and kind of continuous testing frameworks, as one can expect from any modern software project nowadays. There is Fossology for the managing the IP rights of the software components that people submit in. So you should always know what kind of software licenses are there in the build, which is surprisingly difficult in a larger project, because people might submit software that has some license that might not be compatible with the rest of the system. And as you might be aware, that's pretty big problem in bigger commercial software, or even non-commercial, of course. Then IP policy and how the IP components are managed in the integration cycle. Fossology is the tool's name. Some of the development tools that are used, nothing out of the ordinary, one could say. Tool chains, debuggers, profiling, tracing, SDKs. Then security, which is kind of where my personal background is over the years. So I could kind of let's say summarize it briefly, that the Oniro security comes with the necessary components that you can build a secure product and even certified to be secure if you so need to do. PSA is a kind of ARMS certification standard, and this trusted firmware, or TF A and M, it's for the Cortex A and Cortex M ARM devices. Kind of the basic low-level services to do this extra secure services that are needed in certain applications. Secure boot, and then this trusted execution environment is a kind of concept where some part of the software is run in a contained, very secure environment where, for example, cryptographic keys can be accessible, and then many kind of security critical services can be built with those. It is something that every mobile phone has had for many years already. Those are the kind of building blocks for, let's say, security technologist people, but then the practical security essentials that every device will need and will benefit are these kind of quality assurance of continuous integration. When the system is built, there are efforts to make sure that there are no known faults in the integrated software. All the tests we can imagine are executed, and then we will follow known vulnerabilities and exploits in this common vulnerability and exposure process, CVE. So that is established, and then whenever problems are found, there are means to update the fixed software to all the devices out there. And this is logistically actually quite complex effort, because if you make a small mistake and you submit the new software to all your devices and you happen to break them all, then you are in serious trouble. So this is something that the mobile phone industry has been facing for 20 years, and it's now the knowledge is kind of gathered in this Oniro effort. Then connectivity is what one can expect in an IoT, let's say, modern IoT system. Blueprints was I already mentioned, and there was the vending machine, smart gateway, door lock. Okay, so we have used 45 minutes on my almost monologue. Thank you for the few questions, and I could actually interrupt here and give the floor to discussion and questions. The practicality I would suggest for your next step is to go to this oniroproject.org webpage, and there, first of all, go to this quick build page, or I can show the com, that was org. Oniro. Oniro, noin. Ei vieläkään, not yet, sorry. There go to resource center and their documentation. And there the Oniro quick build. And there you will find, you can cut and paste these command lines to your Linux box. And after this very short instructions, you will have a QEMU running the Oniro image. And you can boot it in your PC environment, and you can see how it works and play around with it. And after that, if you like to, you can get some of the reference boards. Easiest, I would say, is here in this picture is the Raspberry asset, which is in this picture connected. And you will get a command prompt on if you connect it to a HDMI display. And then if your interest is more to the, let's say, so small devices that they can be battery operated, then it's this, for example, this Nordic semiconductor board. Or then you can stay with the devices that can actually run full Linux, like the Raspberry.